All right, my name is Melanie Mead. I'm the Education and Outreach Coordinator here at SOFO, the Southport Natural History Museum, and welcome everyone to another presentation of SOFO Zoom. Tonight we're going to be listening to Dr. John Tanacredi. He is the director of the CERCOM laboratory, that's the Center for Environmental Research and Coastal Oceans Monitoring, and he is going to talk to us about horseshoe crabs, their ecological importance, and their worldwide and local importance to humans. So even though there are a few people still joining, I think we'll let John begin. So John, you can go ahead whenever you're ready.
Okay, Melanie, thank you so much. Really appreciate it. Good afternoon, everyone. I'm just going to give you a little short bio on how I've been involved with horseshoe crabs a few years, and then go into to a little bit of their biology, their ecology, and but most important today, the relationship to COVID-19 and the long-term aspect of your health. I've been involved with conservation, ecology, biology since undergraduate work, graduating, and from high school, I worked as a docent at the New York Aquarium and studied under, at that time, Dr. George Ruggieri, who was the director of the New York Aquarium at that time called the Wildlife Conservation Society, or the New York Zoological Society. And the reason I mention that only, since it was way back in ancient history, 1965, 64, was that he wrote a book which was very inspirational to me and called The Healing Sea. And he talked about pharmaceuticals for marine organisms. And most of the time at the Zoological Society, there was a constant attention to the pharmacological development from marine organisms. And they play a big part of this, certainly with horseshoe crabs in the 1950s. And the idea of the blood, the extract from the blood of horseshoe crabs in the 1970s has been an important part of this, and I'll get into that in a little bit of detail. I was a meteorologist with the United States Navy, and I was a hurricane hunter, flew about in hurricanes for 3 years, 1967 through 1970. I worked with my PhD is from Polytechnic Institute, or it was a university status for a while, but it's now part of NYU's Tandon School of Engineering. I worked on Governor's Island with the United States Coast Guard as an environmental analyst for 4 years, working on bridge and highway construction. Why that's important is that most of the bridges and highways on the east coast of the United States has some kind of impact on wetlands. So wetlands and wetland organisms, estuaries, are a big part of my background and experiences there. And then for the next 26 years, I was a research ecologist with the National Park Service, Chief of Natural Resources at Gateway National Recreation Area in New York. But I was the coastal coordinator for 9 years at the University of Rhode Island at the Graduate School of Oceanography for the National Park Service in establishing what are called cooperative park study units. And part of this had to do with habitat preservation and protection, and horseshoe crabs are a big part of that. I was chair of the Department of Earth and Marine Sciences at Dowling College for 13 years. I left there in 2013 and have been the professor and CERCOM director at Molloy College ever since. And we have expanded quite a bit of it. We're the only captive breeding laboratory in North America and in the Western Hemisphere. The only other laboratory on Earth is in City University of Hong Kong. And we produce about 20,000 juveniles, horseshoe crabs a year. Most of them are used for educational purposes and understanding their biology and for experimentation. But we also conduct the largest inventory of horseshoe crab habitat and horseshoe crab numbers on Long Island. The CERCOM horseshoe crab inventory this is its 20th year. We did it through the pandemic. And we go to 115 locations, which I'll mention about a few of them, but 115 is the largest, most comprehensive inventory for horseshoe crabs, certainly in New York. So Limulus in the limelight. It is important to to know that this is not a talk about dinosaurs. And the only reason why I mentioned that is that it could have been. The idea of horseshoe crabs have 4 basic important attributes, if you will, that contribute to their significance and what ecologists call seminal species, species that are critically important on a global scale and on all of to human history, and for all intents and purposes. These animals crawled about under the legs of brontosauruses. They are basically part of the early Paleo-ocean. They are part of just kind of a step over the Cambrian into the age of invertebrates, which was the predominant groups of organisms that existed on the planet at the time. So 455 million years, they shared that Paleo-ocean with these creatures, Eurypterids, which trilobites, if you know anything about the trilobites, they were the predominant life form in the Paleo-oceans. And then the horseshoe crabs, if you were to take a look at Paleo-Limuli, which is a fossilized remain of Limulus polyphemus, which is the primary horseshoe crab, and take a look at its physical factors that are associated. Again, it's not a crab, it's not even a crustacean generally, though some crustacean biologists do include it. It does have an exoskeleton. It has book gills that are very much like insects. It's in the insect grouping of living organisms, and most of the organisms that were trilobites are all gone. They're extinct. But in this major family, which has kind of expanded, which include arachnids and spiders and scorpions, are where the horseshoe crabs are, called Chelicerae. And the reason that they're called Chelicerae, by definition, not so much in these early trilobites, but because their food or their mouth parts are surrounded by their legs. And they have these small little legs called pedipalps, which push food into their beak area and their mouth. And here's a picture over here, Mesolimulus or Paleolimuli. And most of the work we know about, or most geologists or anthropologists that know, paleontologists rather, that know about horseshoe crab evolution, look at their molts. They're invertebrates, so their growth is in molt. And interesting thing about horseshoe crab molting is that they're not sexually mature until they get to their terminal molt. Males molt about 9 times, they molt 16 times over 9 years, and females will molt 17 times over 11 years. So there's a asynchrony there that's very important, and it has to do with how long these animals have been able to survive. Again, through all of this life cycle and development, they've basically survived 5 mass extinction events. The last mass extinction event occurring 65 million years ago, the creation of the Chicxulub crater in Mexico, where all of these ancestors, all of these organisms, any organisms that were invertebrates in the early ocean disappeared, but horseshoe crabs have survived. And so surviving all of those activities brings us up into the 19th century, early 20th century, and horseshoe crabs were harvested immensely, in immense numbers. Here's something in the neighborhood of about a million or 2 in this portion this is in Delaware Bay at the time, and they were used for fertilizer. They were chopped up and ground up and used in fertilizer. Obviously the females, which are when they're gravid, and then most of the time they're producing eggs all the time, between 80 and 120,000 eggs per female. You can imagine this is kind of a protein bonanza when it comes down to these organisms. But the idea of fossilized fossil fuels were the saving grace for horseshoe crabs, because basically chemical fuels and chemical fertilizers supplanted and replaced horseshoe crabs that were harvested along the east coast of the United States. And we'll talk about their range in a moment, but this is their basic habitat. This fragile edge we call here our barrier beaches and barrier islands in the nearshore ocean. This is the Hudson River. You can see here coming through what is called the New York Bight. The Bight apex runs from the tip of Montauk out into the Atlantic and then off into Cape May, New Jersey. And the Bight complex is covered under study by the US EPA in its National Estuarine Program, part of the Hudson Raritan River estuary coming out into the ocean. And then, of course, here is Great South Bay that's covered by its estuarine resources by the New York State Department of State and the South Shore Estuarine Reserve Council. And then we have EPA in New York Harbor, in Long Island Sound, and not on this picture, but way out east on not far from you in Peconic Bay. And all of those national estuarine programs are constantly looking at the health and the environmental quality associated with these types of ecosystems, because they're the most productive ecosystems on the planet. 90% of all the fin fish and shellfish that's consumed around the world has some portion of the species life cycle in estuaries, and they're called nursery grounds for that particular purpose alone. The idea that estuarine systems are unique for ecologists because they're transition zones. They are basically the ecosystems that occur between the terrestrial systems and the marine or ocean systems. And those types of systems are called ecotones. And ecotones are very, very dynamic. They're constantly complex interactions with the resources, living resources, and the non-living resources associated with the nearshore ocean. The coastlines are major attractors. Walt Whitman wrote about visiting the shore in the wintertime, walking along the shore. It's not only it's habitat protection in helping production of food and other resources, but recreational, going back to the ocean, returning to the shore, where basically life moved onto the terrestrial terra firma in Earth history is a thing that everyone does, and many people want to live there. As a matter of fact, every man, woman, and child in the United States spends at least 10 days a year, minimally 10 days a year, in some kind of coastal recreational activity. 2/3 of the people that live along the east coast of the United States, which has tripled in numbers of people and development over the last 75 years, tripling in that number, are within an hour's drive of the coastline. And there's all types of pressures associated, not just with visiting the shoreline, not just using the shoreline, but inhabiting the shoreline, which is basically part of the infrastructure, everything from roadways and wastewater discharge, all the types of things that are associated with society. All of societies are in human history started in some type of closeness to a shoreline, whether it's a river, but certainly to the ocean was a big part of developing cities and in development. And they developed it in these types of habitats. Spartina marshes, again, the most productive ecosystem, these estuarine systems in the world. We need to really have a greater attention to them. We know by looking at them, just by this picture alone, we can tell if horseshoe crabs inhabit these areas, because they come onto shore and full moons, high tides, new moons and full moons, high tides, and they divot. They will nest 3 or 4 times. They put those 120,000 eggs into the sediment, and you can see here's some remaining situations where horseshoe crabs have been noted. You don't necessarily have to see them to see the breeding activity. But then you have this type of circumstance. There are pressures from that infrastructure: jetties, groins, bulkheads, rock riprap, housing. I just wrote a response to a news item after the hurricane seasons of any year, and having been involved with hurricane monitoring for several years when I was in the Navy, the concept of the impact along the coastline is always bantered about as it's costing more and more and more. It's costing more and more because there's more and more infrastructure. Just along with Sandy, which wasn't even a full-blown hurricane, it only got to 75 miles per hour. It was called a superstorm primarily for insurance purposes. But the idea with Sandy was $60 billion just in New York alone for the infrastructure replacement and restoration. So these types of barriers, if you will, do have some impact on the animals, but it's not the major impact on the animals because these animals have been pretty resilient. They've gone through dramatic changes in their environment over that 445 million years. And so something like this is not the major concern at this point, but it is something that we have to be considerate of because these coastal habitats are dwindling more and more. The mud flats are usually areas that, you know, they don't smell too, people don't appreciate necessarily the interior of these types of habitats along mud flats and marshes, but they're critically important because these animals also have a service in the marshes and wetlands. It's called bioturbation. They're part of animals that move along the sediments. I've had, when I was with the Park Service, we had our scuba divers in the Rockaway Inlet looking at horseshoe crabs as they actually came in, and they kind of come in and graze along mussel beds, all the blue mussel, Limulus, and they come into the estuary and they turn over the sediment. So they're really part of the kind of the micro environment associated with benthic areas, which are the critical parts in estuarine systems all the time. It's the places where mosquitoes may lay their eggs, the places where sediments, certain kind of contaminants can be adsorbed onto sediment particles, and therefore one has to be concerned about that. This is one of the issues associated with dredging, what the impact would be there. And so these animals maintain the relative, what we call bioturbation in estuaries, and they provide food for other organisms as well. This is a picture of one female here, and there are a few males about. The female, and when you look at the physiology of the animal, you can tell the male because its first appendages are little hooks. They attach to the female. It's called amplexus. The female will deposit some eggs, and the male will fertilize them. And then there's a host of other males that come about. They're called satellite males, and so they all will contribute some fertilization, but only the one male attaches. Once that one male leaves, other males will come about. So this is one of the contributing factors associated with their survivability, the ability of this tremendous genetic diversity. But even having said that genetic diversity, these animals are found usually in the same sites that they were basically spawned in and have been tracked back to as adults, meaning that they have tremendous site fidelity to the location. And that's another, it's a problem, but it's also a good contributing factor. So as long as the habitat is there, as long as it's a viable habitat for the animal and there's no other pressure associated with it, this animal will come back to breed. And the range of Limulus polyphemus North American horseshoe crab is from Maine to the Gulf of Mexico, around Florida, to almost about near Tallahassee. You can literally put a flag on the beach in Tallahassee and the tip of the Yucatan Peninsula. That's its range. So animals are but this picture is taken from Delaware Bay. Delaware Bay is the epicenter. It's the main number, some 4 to, and we really don't know the number, but we've had numbers from 4 to 12 million associated with Delaware Bay. But it's the only portion along the east coast of the United States for Limulus that is stabilized, relatively stabilized in its population over the last 5 years. And why I mention that now is that New York State has been declared over the last 3 years as poor management of its horseshoe crab populations. And I'll get into some of the details of that, but this is one of the reason, and the main reason is because this animal is protected in a biosphere preserve called the Carl Schuster Preserve, named after Dr. Carl Schuster from Virginia Institute of Marine Sciences, who was the world authority. He was 92 years old. He just passed away this year. And so he was an amazing authority on horseshoe crabs and identified the fact that if you can preserve their habitat, and again, they're migratory, so they come ashore only from May, and they're around until sometimes early September, possibly into October, but they're finished their breeding in June and July. That's their peak breeding period. And so all of these animals come ashore at the exact same time in the transfer or the migration patterns of a host of other organisms, including, well, just as another picture here of the males will come ashore, females come ashore, the males come after that. And here's in amplexus. You can tell an organism when it's sexually mature because it has this breeding scar from the prosoma of the male. Males are always smaller than the females. That's called sexual dimorphism. The females are always larger. And so this is a breeding pair, and this is the sites. You'll see these tracks and trails in the sediments all the time. And mud flats are their critical habitat in the coastline. Just a few pictures along here. They're also habitat for a host of encrusting organisms, barnacles. I've seen algae growing on, you name it, it grows on these animals. They have a symbiotic invertebrate that lives within its appendages. There's a host of other organisms, but the key is its molting. And the molting process, we've been doing for the past decade work on changing in pH. Now there is the idea that the oceans have changed in their acidification. There is some supportive work in that category, but we took these animals because they come into estuaries, which are really where the discharge of water from runoff or from atmospheric washing, rain precipitation events, from wastewater systems, all of the things that go into the estuary influence its chemistry. And that chemistry has some subtle impacts on invertebrates before it gets to vertebrates. And again, there's no bones here, it's all exoskeleton, and this is, it crawls out of its front of its what is called prosoma. And starting in May, late April, early May, the first full moon, new moon, you'll start to see animals coming ashore. But by the time June and July, the numbers get up onto the shoreline. Here's the undercarriage. Again, they are chelicerae, so they have these book gills. This is their gills are here, but there's tons of encrusting organisms. This is slipper shells and barnacles. Their tail, the telson, is used only for turning the animal over. If it's in amplexus like this, it's a lot more difficult, but they only do that. We'll talk a little bit about their eyes in a moment, but there's about 5 or 6 what are called ocelli. Those are primitive eyes. If you've ever seen scallops, you see these little dots along the outer portion of a scallop. Those are the same type of things. They're light sensitive organs. They're primitive eyes that help these animals. They're basically linked to lunar cycles and luminosity of at high tide and full moon. So here's there's a group of there's an organization called Green Eggs and Sand for that. This is one clutch, if you will, of horseshoe crab eggs. And again, the numbers, and this is kind of a protein source. About 21 days, the animal will hatch into a larval form, and then they grow to juvenile stages. They get about 3 or 4 of the molting cycles, though there is a pre-molt even inside the egg case. But you can start to see their compound eyes and their telson, and they're basically the trilobite look, and that's why they're called trilobite larvae. But the animal itself is pretty amazing. Some of these eggs can remain in sediments and in the sand, and actually there are eggs that survive winter and potentially can contribute to hatchlings in the following season. Horseshoe crabs in the red areas here are the only places they're found on Earth. There are only 4 species of horseshoe crabs, and only one here in North America. Here's the Yucatan, and there's Tallahassee around Florida, all the way up to Maine. In Asia, there are 3 species, two are called Tachypleus, and the other's Carcinoscorpius, and different from Limulus. But if you put them all next to one another, more than likely, general public wouldn't be able to differentiate them. There are slight differentiations, but nothing dramatic. They're found in the Bay of Bengal here in India, mostly Carcinoscorpius here, Tachypleus. The 2 species are found here from the southern island, only one island in the southern portion of Japan, Korea, around China, Taiwan, into Thailand, Indonesia, Cambodia, Vietnam, and parts of the Philippine Islands, and that's it. They're not found anywhere else. This is makes it, again, this exclusivity is another factor. This may be an artifact of that's paleo survival, but the idea of these animals being redistributed or reintroduced is very difficult in other habitats. They aren't found in these particular habitats. They're unique to them. The exact same time that the animals start coming ashore and nesting, then it's just a cornucopia of eggs for tons of birds, millions of birds. Many of these birds are critically connected to horseshoe crabs, red knots, ruddy turnstones. Any of the shorebirds, the classic shorebirds, are constantly, they're just pecking away, consuming, doubling, tripling their weight just on these eggs in a relatively short period of time, several weeks or so, June and July, and then they're basically on their way. But that's the major contribution. But everywhere in this intertidal zone, the littoral zone, from the extreme low waters to high waters, contributes to these eggs on the shore so other organisms can do them. And then the juveniles, if they hatch, are there. All types of plovers. Just if you ever have a chance to get down to Delaware Bay, on the Delaware side, there's a beach called Slaughter Beach, no connection to the animals, but it's just this amazing sight and scene to see the numbers of birds and horseshoe crabs just littering the coastline, the intercoastline. And again, all types of birds, herons, what have you. As I mentioned, some of these animals, not really absolutely clear, but some animals tend to have a lot more incrustation than others. If I could answer that question, I'd probably have a Nobel Prize on the line. But it is a fact that they do have a lot of encrusting organisms. And again, the breeding cycle in Amplexus, and anywhere you see horseshoe crabs along the coast. And this is a male that's just waiting for its opportunity. And we measure them across the prosoma, across between their compound eyes, and you can see the compound eyes here. A Nobel Prize was won for studying the eyes of horseshoe crabs, and they've been in the scientific literature for as long as I've been around, and certainly have read just about everything that could be produced in the literature about horseshoe crabs. They're still being studied. As much as we know, that's as much as we don't know about these animals. And again, the attention to them peaks in general prior to 2019 and 2020 because of their uniqueness in coming ashore. And we'll talk about that in a minute in its COVID. they're tracked, they're given some kind of tag, some groups, American Littoral Society, hosts of organisms, high school groups, students will partake in it, green eggs and sand, also do some tagging. There are different tagging methodologies. The only concern about the tagging is that it has to be on a sexually mature animal which has already gone through its terminal molt. If it molts, it will lose this. So it's very difficult to track these animals from the time they become their hatchlings and their juveniles until they become sexually mature. Again, as I said, between 9 and 11 years, which is very, very, if almost impossible, to be honest. And so we try to look at this process in the laboratory. And here's a pair that were both marked. And again, they have a site fidelity. They come back to relatively the same area and beaches. And then anytime a fish haul gets done, this is when I was with the Park Service, we did inventory all the time. We would take animals in and just count them, spider crabs and flounder, blue claws, all of the animals that are associated with the ecosystem, the coastal ecosystem. Horseshoe crabs are important. And many of these animals are dormant in during the colder months in temperate climates, but they do come ashore through this kind of maze of other organisms. And some of these can be predators on their juveniles, on the young. Some birds will go after adults on the shoreline, but for all intents and purposes, their eggs are the primary source for the different species there. Here's one of the compound eyes on the horseshoe crab. And then this is so I mentioned the paleo survivability. That alone in itself as a unique entity should be enough to protect this animal forever, including its habitat and understanding its biology and its ecology. But there is so the paleo survivability and the conservation aspect of it, the conservation component contributes to other species, survivability of other species in these coastal ecotones we call estuaries. But as of 1950s, when the scientists discovered the implications of the blood of horseshoe crabs, which are blue, the blood is blue, it's copper based, it's not iron based like our blood is, and the blue blood is collected. There are 600,000 animals that are collected to remove a portion of their blood. Only they don't bleed them out. They take relatively only about 1/3 of the blood of the animal, and then they're replaced back into the environment that they're in. There are measures that to protect these animals, but they produce a chemical by only 3 pharmaceutical companies called Limulus Amebocyte Lysate. If it comes from the Tachypleus, it's called Tachypleus Amebocyte Lysate, TAL or LAL. And why LAL is so important is because it was understood when you see a wound on a horseshoe crab, it almost takes care of itself automatically. It's not like clotting in the iron aspect of our blood, but it basically detects any kind of bacterial contamination. And here's the key to COVID-19. The LAL is here it says it's only a $300 million industry. That has gone up a bit. It's about 450 million and probably going up even more because LAL is an endotoxin detecting system. It's immediate, it's effective, and it's efficient, and it's been approved by the FDA for decades. And every hospital on earth knows about LAL. I just gave a presentation to 75 nurses at Molloy College in the nursing program, and they all know about LAL because it is used to detect gram-negative bacteria. And why gram-negative bacteria is important is that gram-negative bacteria produces contamination called sepsis. And sepsis has absolutely no cure for it. It's basically, if it's in your respiratory or circulatory system, in the United States today, at this moment, 275,000 people will have died this year from sepsis alone. One out of every 3 people going into hospitals in general before COVID-19 would be mortalities due to sepsis alone. There is just no cure. So the idea of LAL is to use to detect gram-negative bacteria. It's used on every surgical circumstance, every injectable drug, and it's used for QA/QC, quality control, quality assurance of every pharmaceutical that is produced. And here's a couple of notes. In between 2009 and 2015, there were 3.95 billion prescriptions in the United States alone. That has to have some type of quality control. LAL is what does that. Now, there are other products, no doubt, but they're not as effective and efficient and as immediate as the LAL. On a global scale, there were 234 million surgeries on an annual basis, and that's probably even more than that. In the United States alone, there are 25.8 million people with diabetes. I have type 2 diabetes. I have to, anything that I take as a medication, I want to make sure that medication is properly detecting any kind of contamination. And we're talking about now billions, and certainly for the United States, hundreds of millions of injectable immunizations associated with COVID-19. And that's the connection right now. The idea that LAL, horseshoe crabs, and their blood helps in this detection system in the big picture associated with wanting to make sure that certainly the inoculation and the immunization works against the virus, but these are secondary concerns, secondary impacts that can be even more, especially if there's susceptible groups, the elderly, nursing homes, hospital stays, anything associated with the animal. And that's the significance of LAL and its importance in horseshoe crabs. Now, so just keep that in mind. Paleo survivability, the idea of its conservation idea, and this idea of the human health connection. You would think that alone, those 3 alone, could be justification for supporting them. The LAL system replaced the rapid test. Rapid tests took 48 hours, 72 hours, and a lot of rabbits to deal with that. It's totally eliminated that and made it instantaneous as far as the detection. And just the harvesting of the blood of the animals is that critical component and that important part. This is just a picture of some physiology of the animal. I won't go into that in any great detail at this point, but here's the connection to the problem as I foresee it. And for many years, when I was in the Park Service, when I was at another academic institution, and certainly in my 8 years now at Molloy, I've always looked on the side of as a conservation strategy, let's not overstate something. Try to be accurate and try to look at what's going on. And in New York State alone, 135,000 animals are harvested each year. 135,000. It used to be 250,000 15 years ago, but it's been slowly reduced. 135,000, and it's chopped up, thrown into a refrigerator, a freezer, and saved for bait for 2 species that are not a big part of the overall fisheries and the aspects of not only New York, but of the United States. And one of them is along the Atlantic coast, the North American eel. And the idea of eel populations along the Atlantic coast, the American eel, had its heyday in the 50s up into the 70s. The landings of eel landings were tremendous, and slowly they were declining. It is the Asian population of the world consumes many different species out of the ocean. It's a major emphasis, and all type mammal, from vertebrates to invertebrates. But the key here is that on Long Island, this is a kind of a boutique niche in fisheries. I'm not trying to take jobs away from fishermen, but the idea is to look at these animals and to find out a way to either use another bait or another type of thing collect these animals, because here's the issue. The numbers of these animals are kind of stabilized over the last 20 years or so, but their cost, their value has skyrocketed. So this is the concern. And look at the numbers here. The numbers are still declining. And there's the emphasis on these fisheries are noted by the Atlantic States Marine Fisheries Commission, which looks at every state along the east coast of the United States, and the only state that has poor conditions in its harvest, in its maintenance of the conservation of horseshoe crabs, is New York. And one of the contributing factors, and I believe the major contributing factor, is the fact that 135,000 animals are removed totally. They're gone. It's not like you're bleeding them and putting them back. And that alone would be a problem, but they're being harvested before they get onto a beach. They're not even having a chance to breed. They're taken offshore or before they come onto beaches along the shoreline. And that, to me, as a scientist, and in what we're looking at, is a critical concern. Now, there are other places that harvest animals for their blood. As I mentioned, 600,000 animals a year to produce LAL, and these are the states that do that. Didn't have New York on there, but it does have where a lot are being collected. There are other impacts that can influence an animal. This is a fishing line that can be a real concern. These two relatively overly enthusiastic high school students, you don't like to pick up the animal by the tail, but it's not all that big of a deal. But the idea of educating the population and the public about how important these animals are, just in the conservation strategy, should be enough. And if you ever see them on the shoreline, you kind of turn them over. But dating back to 2005, the first international conference on horseshoe crabs was put together, and fast forward to 2009 and 2010, and we had another conference in China, in China and Japan, and the one in China was in Hong Kong, and we went on to mainland China, and they harvest horseshoe crabs in places like Thailand, Vietnam, Cambodia, Indonesia. During the breeding season, will collect 10,000 adults a month, 10,000 a month, totally bleed them out, and then take whatever flesh associated with the animal, put it in little plastic bags, and ship it off to the fish markets to be sold. And on YouTube, you can actually see menus for cooking horseshoe crabs. So here's the issue. Exotic food, bait for fishing, those two can prove the death knell of horseshoe crabs. And here is in Taiwan, they actually have buildings constructed where they put horseshoe crabs, try to grow them and breed them. They actually put nets across inlets all through the coastline. The largest aquarium in the world is in southern Taiwan. It has a whole wing just on horseshoe crabs, because the horseshoe crabs are revered in Japan and Taiwan and in South Korea. And so the idea of this could never happen in the United States. When we were in Hong Kong in 2010 and in Japan 2012, this motley crew here are 6 of the world scientists that work on horseshoe crabs: Mark Botten from Fordham University, S.G. Cheng from Hong Kong University, Paul Shin, Dave Smith from USGS, yours truly, and Glenn Gauvery from Delaware. And so we've been looking at these animals. We have, again, the captive breeding in Hong Kong. This is the laboratory in Hong Kong. This is at Molloy College. Our adults at production of eggs, we can get up to 200,000 of these eggs, and it's really important to have this captive breeding activity. But it's very difficult because these animals everywhere in the world, even in captivity, they get up to the 10th molt in their either 16 or 17 molt cycle of their life cycle. and there's all mortality, and no one can get them past the 10th molt. And what that is being investigated these days, but it's a very difficult concept, but it has nothing really to do with the animals in the wild. These are the larvae, the juveniles, as they hatch out. And once they become juveniles, they're fed certain brine shrimp. We get them up to about the 3rd or the 4th molt, and then we move them into juvenile staging areas. Just some pictures, and then each summer, from starting in June, and we started when I came to Molloy in May. We get to, this is only a few of them. This is but 115 locations. These are all the sites that we monitor. We call it habitat monitoring. We look at the habitat, and if 3 years in a row do not have horseshoe crabs breeding, or we don't see any indication of it, we say that the site is removed out of the breeding cycle. These 115 locations, these are the locations. This is the physiology I mentioned to you. This is the male first appendage. Right here's the female's first appendage. This is for amplexus. But we have documentation, we've had some 50 volunteers over the years. We now work mostly with students and volunteers, but here's the key. Now this, I'm afraid this only goes up to 2016, but this is the inventory, and down through the next 4 years, we've gone almost for 3 years in a row below this value. You might have seen the Newsday article that just talked about that. We just released the this year's report, and the numbers are down. But critically, as an ecologist, that almost doesn't scare me too much, because these animals are very difficult to track. So some years you can have large numbers of animals, and some years you'll have none. It's the idea of how long we don't have them, or how long the habitat is not productive. This is called fecundity, the idea of the ability for this animal to use the environment to produce offspring and to keep coming back. And the inventory shows that we're losing more habitat to the circumstance, or beaches are not producing, and those beaches that are producing produce various numbers over the years. Now, this is going to kind of go through here quickly, but these, just watch how these values here are played out across Long Island. This is a GIS map that talks to and you can see it's incredible variability. Some years there are major numbers, some years there are not as many. Some years there may be 1 or 2 years where they don't have it. So this is the difficult challenge associated with this. But all of that doesn't matter truly if you take the animal out and you harvest it before it can breed and you chop them up for bait. So we, after our first horseshoe crab conference back in 2007, we established a specialist group. It's called the International Union for the Conservation of Nature, IUCN. This is the largest and most prestigious conservation group in the world. It has all of these specialty groups that study a particular organism. We study the 4 horseshoe crabs. And the IUCN has this, Mark Botten and Paul Shin are the chairs, where I'm on the steering committee, and we work on identifying how these animals are faring overall. And we had published our work in a major research publication. We've had actually 2 more, and I'm finishing up a 3rd one that should be coming out in 2021, early 2021, talking about horseshoe crab research around the world. And one positive thing about studying horseshoe crabs is that there are a lot more people. When we first started, you could have counted the number of scientists full-time on horseshoe crabs. Now we've quadrupled that number, and they're all over the world. And in some places you wouldn't think. We have work. We did a conference, a crustacean conference in Frankfurt, Germany, and we had tons of students who are interested in the biochemistry of this animal. We did work in San Diego, California, at a coastal, it's called the Surf Conference, dealing with estuaries. And we had students in California. There are no horseshoe crabs there, but they were interested in studying the animals themselves. So this has become important. We've established that, and it takes 6 years to go through the IUCN process of establishing an animal to be listed on what is called the Red List. The Red List is the International Endangered Species List. It identifies an organism based upon all the data that's available to study them. And Limulus polyphemus has been in this threatened category as vulnerable. It's not quite endangered yet. It's not critically endangered. And it gets to that point, I won't need to make any presentations anymore, but we're at a vulnerable stage. The other 3 species are in this near threatened, and they're data deficient. And so, but they're working on that. We're hoping it's, the IUCN meets in it every 6 years. So in 2023 is the next time that it'll be meeting. And we hope to have these Red List proposals submitted for the other 3 species. That's what we've been working on for the past 6 years since the last, and this is the process, the Red List process. It's a paper chase in many respects, but it's based upon data. And in many parts of the world, like I said, in Indonesia, where they harvest 10,000 animals a month, no one's keeping a record. No one's there taking a picture, identifying them, and no one is telling them that you really shouldn't be doing that. So it's a real concern overall, primarily, not only the conservation aspect of it, but right now, there is nothing as effective, as efficient, and as reliable as LAL for endotoxin detecting systems. Just on this, if there are any teachers in the audience, we have a K-12 curriculum, all on horseshoe crabs. That's pretty neat. And so our teachers use it here at Molloy College. You can find out more about what we do at Molloy, just go to our website. You can see everything about CERCOM and all the things that are associated with horseshoe crabdom. But I think from the standpoint of the conservation strategy that has to, we don't mess up natural systems. That's the primary focus of the UN Conservation Strategy, which was established in 1970 in the first World Environment Day. You don't mess up natural systems. You don't overharvest. You try to have a resiliency by having organisms sustainable population by letting them breed in any of their habitats, and you have to preserve their habitat. So these are types of things that we are fostering in our students in the Bachelor of Science degree program at Molloy. And I love the coast. I'm a born and bred Brooklyn boy, but I can tell you, I try to get to the ocean as much as possible, just to walk along it, just to feel it, smell it, taste it. And even in this COVID time, we've been on the shore this past summer, and certainly during most of the year. So I think with that, that should be the last picture.
Well, thank you, John. I hope everybody enjoyed that as much as I did.
Thanks, Melanie.
And I think John is able to take questions. I can help with the chat. We do have one question in the chat, John.
Okay.
It is, what is the loss in numbers of horseshoe crabs due to the bleeding process? I've heard that we lose about 20%.
Well, I can tell you that I don't know. I'll tell you why I don't know. I don't know a lot of things. And one of the things associated with the bleeding process is, depending on what you read and depending on who you're talking to, I've heard everything from 1 to 3% to as much as 35 or 40%. Maybe it's somewhere in between there. Maybe 20 is a realistic thing. I don't believe it is. But the companies that harvest the horseshoe crabs have put this as the highest priority, and they go through a whole process. And the key is that once they get the animal and that they take the amount of blood that's necessary, and all of the pharmaceutical companies indicate that they have enough of reserve to deal with as many inoculations for quality control, quality assurance from those 600,000 animals. You don't have to take any more than that. And they're all supposed to be replaced back in the habitats that they came from. Now, you notice they came from several states, and there's been an issue, and we don't know what the answer to this is. New York State has an answer, EPA has an answer, everyone has an answer, but if you collect a horseshoe crab, you can sell it for bait. You can bring it and sell it to be bled if the pharmaceutical company is using you. But once you bleed it and you give it back to the fisherman, that fisherman is supposed to bring it back to the place that it was collected. I'm not a betting person, but it's not a sure bet to me that these animals are all getting back into the same habitat. So, and how do you determine if horseshoe crabs have been lost? You'd have to see them en masse washing up onto the shoreline. And nobody has shown me any of that in my 30 years of this situation. So I think it depends on where the source of that comment is coming from, or where you're reading in it and what type of things. There's a lot of competition in there in dealing with having substitutes or a synthetic LAL. And there's a lot of competition going on there, because you can see just from the standpoint of, I mean, no one knew that there was going to be a pandemic. Nobody predicts. I mean, people can predict that, but there's no way of knowing that these will happen. But right now, LAL is a prime resource, and that is a critical part in every hospital, every possible surgery. All the surgeries are unless it's if they're elective, they're being delayed, right? Or even tests, simple things like colonoscopies, which need to be delayed. These are the types of things that are coming about, so that even the slimmest possibility, reducing that type of thing. So I wouldn't put much credence in the value, 20%. It might be real, but in the big picture of things, it's 20% that you don't really have a note on. I can't point to the 20% out in the estuary being lost after being bled, but I can point to 135,000 animals that are removed because they're removed and chopped up, and they're not breeding. They're not even coming ashore. They're getting before they come into breeding. So that not only loses 135,000, it loses that productivity of those 135,000.
Okay, our next question is from John. John, are you there?
Yeah. Good afternoon, Prof. I do not know. It's good morning here, by the way, from Malaysia.
I can't hear you. I'm sorry.
Is it audible, Prof?
Yeah, speak up a little bit.
Is it audible right now?
It's a little better. What question do you have?
Yeah. The question is, for example, from Asia, the thing is, we worked on the revising the red list status of the T. tridentatus, and now it is an endangered. Okay, and what is your viewpoint, for example, how the lal or tal production will impact the animal, especially from the Asian counterpart, for how it's going to impact the harvest of the Asian horseshoe crabs for the tal production?
Right now the concern of the Asian the 3 Asian species is the harvesting for food purposes. That's a critical concern. And also they're harvesting, though we prevented it from happening by sending a letter. This is about 6 or 7 years before I came to Molloy, so it was about 8 years ago, a letter to all of the US states their fisheries commissions saying to please go to the Department of Commerce and tell that it's illegal to bring in horseshoe crabs from other countries, from Asia into the United States. Because I was called, this is going back a decade now, I was called in my office when I was at Dowling, and I was sent an email with a picture of a container at Kennedy Airport. It was on the tarmac. And in that container, there was 600 dead horseshoe crabs. And the only reason why we knew about it is because the smell was pretty brutal. But they opened it up, and on the side of the crate that these were in, or the bags that they were inside this crate, had a telephone number and an address in Vietnam. So we called the number, and we spoke to the fellow in Vietnam. And he said, yeah, we got somebody wanted it for fisheries on Long Island, and they asked for 600 animals, and how many do you want? And so we immediately reported that to the U.S. Fish and Wildlife Service and identified the fact that this has got to end. That cannot be allowed to come into New York or Philadelphia or Washington, D.C., wherever on the East Coast from the Asian horseshoe crabs. And that has, there's no other cases since then that I know of. But that's how reluctant, if you will, the adaptation to taking these animals out of the bait industry, out of the fishing industry, out of the food resources industry, and letting them do what they've been doing for 445 million years, supporting other species along coastlines and their own reproductive strategy. And we happen to use them in the last 3 or 4 decades, primarily because of their incredible endotoxin detecting capability. And it's probably the reason why they've survived these 5 mass extinction events in Earth history as one of the contributing factors along that line. So we're working with, on our IUCN's scientific specialist group, we have a dozen scientists from China, Korea, Japan, Indonesia, Singapore, and we're all working together. It's a great group of scientists, and we just had, just before the COVID pandemic, before it was last June, they had a conference in China. I couldn't make that one. My last conference was the Japan conference, and so we've been working on this book, which includes their work, but there's still a lot of work to be done. But the scientists in the Asian countries are just spectacular. They're really dedicated, and in Japan, in South Korea, and it's just now being looked at, that K-12 curriculum is being used in the schools in those countries. So, and they were a major part contributing to helping put that together. So that's a very, very good sign. We start with young people having an appreciation for these animals and get it into the K-12 curriculum.
Thanks, John. Next question, what is New York State doing to conserve these animals?
New York State has a permit system. We're part of the permit system. We get a permit to keep the animals in our laboratory. We're not allowed to release the animals, and we're not allowed to release the juveniles. It's been a controversial debate. We've been back and forth for years, but it is what it is at this point. Hopefully that'll change into the future. And they monitor, they have a few sites with Cornell Cooperative Extension that monitors, I think it's a dozen or so sites, but nothing like the 115 that we do. We are a qualitative project, meaning the idea is getting to the beaches and seeing indications. If you want to monitor a site totally and quantitatively as much as you can, you have to kind of camp out at that site and be there over the entire lunar cycle and be able to do that. That's very labor intensive. And so the state has funded Cornell to do that. They've been doing that. They started out in like a few sites, and I think they're up to about a dozen sites right now. But we have 20 years of data for 115 locations. And as you saw by those charts where the various goes up and down, we've provided it to New York State DEC. It's up to them whether they use it or not. And we've had a couple of meetings just recently. I missed one meeting, but we hope to have something after the first of the year, supposedly, to talk more about this. But if you want to know the details, you should go to the New York State DEC website. It's a permitted project. It's law enforcement. It's basically monitoring these crabs, but there is the little glitch. The idea is if you harvest them by net and trawls offshore or before they can come ashore, you're taking them out of the breeding cycle. And I think they changed it this past year a little bit, where they said no collection a day or two around the peak full moon and new moon, and that's a step forward. There's no doubt about it. But we're at a point right now where these animals need to be protected, and I've suggested that there's a moratorium, and put a time frame on it. Give it 5 years as a moratorium, and then put attention to coming up with a synthetic bait or another bait that could be utilized for conch and eel, which is basically, again, not a large fisheries that we're looking at here, and then see what happens then. But right now, continuing to allow these animals to be totally lost from the breeding population, I think needs to be modified.
Thanks, John. Can educators download the curriculum on horseshoe crabs from the, is it the CERCOM website or?
Yes.
Website?
Yes, we have it on the Molloy College CERCOM website. If there's any problem with that, just email me. We'll find a way to get you the curriculum.
The same person asked, I've heard horseshoe crabs are called vacuum cleaners of the bays. Let's go.
Yeah, they kind of are. When I was with the Park Service, I had a spectacular relationship with our park police unit. They had a scuba diving team, 5 police officers dealing with all types of things. If you remember anything on Long Island, the TWA incident, a crash off Long Island, and 9/11, all the types of things. They're just tremendous resources. And but every once in a while, they wanted a little treat to get involved with natural resources. So I asked them, could you help me out and go on the bay bottom or the inlet bottom in Rockaway Inlet, and at times when we can track horseshoe crabs, and we got this all on video, and we watch the horseshoe crabs come into the bay, and there's all these mussel flats. It looks like somebody rolled out a mat of mussels, blue mussels, and the horseshoe crabs come in. Sometimes they use their book gills and their epistosoma, which is the second part of their invertebrate carapace, and they kind of swim like this. They come down to the bottom and they move along the bottom, and they are like, they're called detritivores. They eat mostly decomposing and dead or whatever. They just march through and vacuum clean through those mussel beds, and it's an amazing scene to see, even in the current, because the tide current coming through there is pretty intense through the Rockaway Inlet on an incoming tide and an outgoing tide. But these animals move about to feed as they come in, as the season starts to bloom.
Okay. Is it possible to farm horseshoe crabs in order to use their blood?
Say again?
Is it possible to farm horseshoe crabs for their blood?
Well, here's the concern about that. I'm waiting. We've through the University of Maine and their aquaculture group, we've put in a proposal, and hopefully it will be successful, because we are actually looking at that. Again, their life cycle, you'd have to have, if you do it from eggs and you try to get them up to where they're sexually mature, or where they can produce the blood to be able to be harvested without impacting them, it's 9 or 10 years. So if you were to harvest animals and hold on to them in a laboratory, they do that in, as I showed you, in Taiwan, southern Taiwan, and they have a different species. Tachypleus is a little, doesn't produce as much blood as Limulus, and it's a little more concentrated, but the concentration for LAL is from Limulus. So it would have to be able to produce enough for animals, and it's just, I think the statistics that are used, Carl Schuster, the world authority on horseshoe crabs, would say 3 in a million, 3 eggs out of a million eggs have a potential to become adults, but then you got to wait 9 to 10 years before that process happens. So they're not the ideal aquaculture organism, and that's what's so disconcerting to me about, we're not allowed to release these animals. We have something called the Crab Club. We have 20 right now, about 20 some odd, 28 high schools that we give from our lab. We didn't do it this year, but we, because COVID and the high schools are kind of closed down, and we give them 1,000 eggs, and they raise the animals, watch them hatch, feed them, and then report on it, and then return the juveniles or the whatever survives back to the lab. And so we keep them in our special portion of the laboratory for the juveniles. So, but the aquaculture of horseshoe crabs is complex, but we're exploring that. We're looking into that. But you wouldn't have to worry about harvesting them, and as long as they were removed from bait, and that they could be continue to be. Do not suggest that they not be collected for bleeding, because the impact is not inconsequential as compared to the removal for bait.
Okay. Do they have to bury their eggs in order for the eggs to hatch? John Kay has seen them massing on hard grass flats, seagrass flats, where it doesn't seem possible for them to bury their eggs.
Well, if they're at the surface, there's predation that takes over, and there they put them in the sediment. It's not that deep in the sediment, it's a few inches or so, and they have to be aerated, certainly. And yeah, I mean, there's a tremendous, the birds triple their weight in the time that they're feeding on these eggs. And again, we're talking about, someone asked me once, how many horseshoe crabs are in Delaware Bay? And I see numbers 4 million, 12 million, 18 million. We don't know. Nobody knows. So, but the numbers that come ashore, and if they're putting eggs in, if they're nesting, they do put them below the surface in these little divots. And some of them can remain in the sand if they're not consumed until the next year. And those are viable if they're fertilized. And I mean, it's like any living organism. There's mortality rates, and hopefully the mortality rates are reduced if the habitat is protected.
Another technical question from John from Malaysia. Is there, I think he's asking if there's a synthetic alternative to LAL. He asks why BET users do not use RFC instead of LAL or TAL.
RFC is not approved by the Food and Drug Administration, and that is it. Until the day it's approved by the Food and Drug Administration and shown to be as effective and efficient, it might have a chance. But right now, none of the RFC products coming out, and there are pharmaceutical companies that swear by it and show the results, and it's been in the published literature, and I'm not denying that, but the process in the United States, as with COVID-19, is the Food and Drug Administration puts it through a rigorous, long-term observation and quality control, quality assured product, so that you don't have to worry about it. So at this point, it's not the listening to the pharmaceutical company. The pharmaceutical company has to get the FDA to approve that. And there's two, you know, in Europe, it's called pharmacologica. There's a kind of a group of pharmacological attention or defenders of this thing, and it's, you know, it's a business type of functioning, an economic type of functioning, and it has efficacy biologically, ecologically, and there are other types of detecting systems that in Europe are used, and you know, that's fine. I don't have stock in a pharmaceutical company worrying about that type of thing. I'm just saying that in the United States, if you're going to use some kind of medication, drug, or pharmacological product, it has to be approved by the FDA. Until that happens, again, that is a big part of the bleeding, the blood, the LAL, the COVID-19 connection. But this is not a new issue in harvesting horseshoe crabs for bait, and it's under somewhat of a control. But this is you know, there's a solution in plain sight here, and that solution is a moratorium for bait, and that it can continue to do the bleeding, it continue to do the educational portion. I mean, we don't even bring into the laboratory the numbers of horseshoe crabs we're allowed to bring in by our permit. We're allowed to get like 30 or 40 crabs a day. We don't do that. We have a certain number of breeding pairs, and we maintain those in our laboratory for study, and that's basically it.
Okay, that was our last question, but for all those who were asking if the presentation will be rebroadcast, it has been recorded, and you'll be able to find it in future on the SOFO media page. You can find it on our website, and it will be posted to our YouTube channel in the future. So thank you everyone who tuned in, and thank you greatly to John.
Thank you, Melanie. Really great. Good to see you, and we'll talk again.
All right.
Be well.
John.